Welcome. Before we start working with SQL, I'd like to clarify what a database is and what SQL is. And I also want to talk about why it is very advantageous and useful to learn SQL. Google tells us that a database is a structured set of data held in a computer, especially one that is accessible in various ways. And of course, Google is right, a database is a structured set of data held in a computer. And of course, we can also access that data, otherwise there would be no point in having databases. A database is kind of a general term. We will be working with relational databases. A relational database is a digital database based on the relational model of data, according to Wikipedia, and of course Wikipedia is right. Simply put, a relational database is a database in which data is stored in tables, and these tables have columns and rows. So it is actually kind of similar to an Excel worksheet. You could think about an Excel worksheet as a table, and of course rows and columns are also specified for worksheets. A software system used to maintain relational databases is a Relational Database Management System, RDBMS. The RDBMS that we will use in this course will be the MariaDB. You might have heard about MariaDB, or you might have heard about MySQL. You can think about MariaDB as a version of MySQL. What is important to know is that for our purposes we will use MariaDB to create our relational databases and our tables. Many relational database systems have an option of using the SQL structured query language for querying and maintaining the database. So SQL is a programming language specifically used for querying and maintaining a database. SQL is also pronounced as SQL, but I prefer to pronounce it as SQL. It is a standard language for accessing and manipulating databases. It stands for Structured Query Language, and with SQL you can access and manipulate databases. SQL has also become a standard. However, there are different versions of the SQL language. The SQL code that we will write will be, I think, at least 95% standard. But keep in mind that we will use MariaDB, so for sure the SQL that we will write will be compatible with MariaDB. With SQL, we can execute queries against a database, we can retrieve data from a database or insert records into it, or update records or delete records, and so on and so on. So SQL is a very specific programming language, but we can do quite a lot of things with SQL. Just like VBA, it has its own syntax. So when we want to use SQL to manipulate a database, we have to make sure that we are writing good, valid SQL code. You might wonder why it is useful to learn SQL and the basics of databases after learning Excel and VBA. As I've mentioned, you could consider an Excel worksheet as a table in a database. An Excel worksheet has rows and columns, and you can store data in it. But an Excel worksheet has only around 1,048,000 rows, so if you wanted to store 10 million rows of data, for example, then you would need to use 10 worksheets. And it would be very hard to maintain your data. It would be very hard to work with your data. It would be very, very error-prone as well, and probably it would be slow as well. Databases are much better at storing data than Excel. And although we can store much more data in a database than in an Excel worksheet, SQL makes it possible to retrieve that data blazing fast. For the job market, it is a very useful skill to understand data. You know how you can work with data in Excel. You also know how you can automate Excel tasks. But now you will also know how you could retrieve data directly from a database. So you will really know your way around data. The people who can work with data, and don't forget that data can be quite complex, are always desired by companies. So once you add knowledge of databases and SQL to your already impressive Excel and VBA skills, you can be sure that the job market will have a place for you. And usually not a bad place. As I've mentioned, we will use MariaDB to work with the database and its tables. Of course, we have to install MariaDB on our computer. Actually, what I'm about to install is XAMPP. XAMPP is a PHP development environment, so actually a lot of web developers use XAMPP. PHP is a language for web development. Because I'm doing web development, I'm very familiar with XAMPP, but of course we will not do any web development, we will use the SQL language from our VBA code. Despite not doing any web development, I think XAMPP is a great choice. It's easy to install it and simple to use it. XAMPP is sort of a software package. Apache is a software that makes it possible to use our local computer as a server. MariaDB, of course, is the relational database management system that we're going to use, and PHP and Perl are programming languages that we will actually not use in this course. Navigate to apachefriends.org in your browser and download XAMPP for your platform. I've gone ahead and I've downloaded the installer for XAMPP for Windows, but there is also an installer for Linux and for OS X as well. Once the installer has been downloaded, click on it. Of course, I will allow XAMPP to make changes to my computer. Don't worry if you get this message box about the antivirus software. You can simply click on yes to continue the installation. Don't worry about the warning either. You can click on OK and there should be no problem installing XAMPP. Once you reach the setup dialog, click on Next. And here you can select the components that you want to install. The whole XAMPP environment takes up approximately 700-800 megabytes on your hard drive. So if you have enough space, you don't have to deselect anything. But what we need for sure is Apache. We can actually not deselect Apache. So what we need is Apache and MySQL. And MySQL is actually MariaDB. And we also need PHP admin. So the rest you can deselect. But because I have more than enough space on my hard drive, I will just install all the components of XAMPP. So I will click on Next. The default folder works for me. And I want to use XAMPP in English, so I will click on Next again. I will uncheck this option, Learn more about Bitnami for XAMPP. And I will press Next again. So now we are ready to install XAMPP. And after I press Next, XAMPP will be installed on the computer. It takes some time to install XAMPP, so be patient. However, I will fast forward the video, so you will not have to watch the whole installation process in this video. So I will click on Next and I will start installing XAMPP. Once you see this dialog, it means that XAMPP has been successfully installed on your computer. You can leave this option checked and you can click on Finish. This is the control panel where we can start MariaDB, and MariaDB is actually MySQL here. In the XAMPP control panel, click on Start. Actually, click on the second Start button from the top, so we will start the MariaDB service. Don't worry about seeing MySQL here instead of MariaDB. Earlier I said that you could consider MariaDB as a different version of MySQL, which is kind of partially true. I know that it is confusing that I'm talking about MariaDB, and the ApacheFriends.org website also talks about MariaDB, but on the control panel we see MySQL. But this should not confuse you. Whenever you see MySQL, simply understand it as MariaDB. Once you've started MariaDB, then click on the admin button. Once the service is running, then the admin button should not be grayed out anymore. Your browser wants to navigate to localhost/phpMyAdmin. However, at this point the site can't be reached because actually we have to start the Apache service as well. Now that Apache is running, we can refresh this page. And now we are in phpAdmin. phpMyAdmin is a software with which we can work with MariaDB. With phpMyAdmin, we can handle the administration of MariaDB, to be more specific. Don't worry about the name phpMyAdmin. We don't have to use the PHP language here. It is called phpMyAdmin because actually phpMyAdmin was written in PHP. but you don't have to know any PHP to use phpMyAdmin. In your browser, you see that we are at the address localhost/phpAdmin. So this is how you can reach phpAdmin once you have started MariaDB and Apache in your XAMPP control panel successfully. Localhost refers to your local computer or current computer on which you have installed XAMPP and the computer that you are currently using. So now we have a local database server running. So this database server is running on our computer and it is only available to us. For learning purposes, it is perfect. 127.0.0.1 is just another way for referring to localhost. Our database server is MariaDB, and you can also see the version of MariaDB here, but it is not that important to us. What is important is that we are the root user now. So there is a user called root, and this root user is accessing MariaDB via localhost. At this point, this root user is not password protected. Let's change that. Let's go to user accounts, go to the last line where the username is root and the hostname is localhost, and click on edit privileges. Now click on change password, and I will choose a very, very bad password, 1234 1234. phpMyAdmin tells me that this is an extremely weak password, which is true, and you should never use it once you're working on real stuff. But because we are learning now, I don't want to overcomplicate things, so I will just retype this very weak password. And I will click on Go at the bottom. You should see this message on top. The password for root at localhost was changed successfully. So now our database is password protected. But we are not finished. I will go back to the XAMPP control panel, and I will actually close this tab. And again I will click on admin, so I will get to phpMyAdmin. And now I receive an error, so the access is denied. And now the access is denied, of course, because we have set a password. So now our database server is protected, so we cannot just simply navigate here and access the database. In order to be access phpMyAdmin using this address, we have to change a few things in the config. Navigate to your XAMPP folder. For me it's on the C drive, XAMPP. And inside this XAMPP folder you should have a phpMyAdmin folder. Go into it. And you should see here config.inc.php file. Open it with Notepad or another text editor, so I will just press my right mouse button. And I will choose Open With and Notepad. I will maximize the window. On this line of your config, so CFG servers I auth type, replace the word config with cookie. And on this line, so CFG servers I password, type the password that we have set. So I will put 1234 1234. After you finish, save the file and you can close it. And now go back to your browser and refresh the localhost/phpAdmin page. Now we don't see an error anymore. We see a welcome page. And here you should put root, so the username should be root, and the password should be 1234 1234. And then click on Go. And now we are back to phpMyAdmin. But this time we were forced to provide a password. So now our database server is at least password protected. There are some databases that are already created. You can see the databases on the left side. We will not use any of these databases, but we will create a new one. This is probably fairly obvious, but I want to be explicit about it, that if you don't want to use MariaDB anymore, then simply stop the MySQL or MariaDB service and also the Apache service. Now if I go to phpMyAdmin, then I will get an error because the database service is not running anymore. But of course, if I want to restart it, I can just restart the MariaDB service and then Apache. And if I refresh the page, then I have access to my databases again. In order to create a new database, we have to navigate to this new button here and click on it, of course. And of course, we have to add a name to the database. I will call this database sales. Once you type the name for your database, you can simply click on create. You don't have to change this value here. So now we have a new database called sales, but there are no tables in the database. Let's create our first table called sales_data. We don't have to change the value in the number of columns field. We can simply click on go. And now we have to define the structure of our sales data table. What we have to do here is to add names for our columns and choose the data type for our columns as well. The name of the first column should be ID, and the type of this column should be big int. Once you choose big int or hover over it, you see a pop-up, an 8-byte integer, and you see that the range is huge. So it means that in this table, every row will have an ID, which will be a number. It will be actually an integer, but the VBA integer is different than an SQL integer or a big integer, because you see that the big int could be a huge number. So we could store a lot of rows in this database table. By the way, these are of course the data types available to us. And I think some of them should be familiar to you. So for example, int stands for integer. But you see that while in VBA the integer can hold numbers around 32,000 or 33,000 max, the integer data type in MariaDB can be a huge number, so it can be bigger than 2 billion. Varchar is a type of string, and text is also a type of string. Date, of course, is a date, but we also have different types of integers. We have a decimal data type, a double data type, and also a boolean. And we also have date and time data types, different string data types. So actually we have a lot of options here. So let's go with the big int data type for the ID column. For this column, I will also check the AI option, which stands for auto increment. So when we will add rows to this table, the ID column will be incremented automatically, so we don't have to deal with manually increasing the IDs. Once I check the option for auto increment, a primary index has been added automatically, but for now we will not talk about it. We will discuss this later. I want to have a column called name. In this column, I want to have the name of the salesperson who made a sale, and I will choose the varchar data type. Usually we use varchar for short strings. I usually use varchar for strings that are only a couple hundred characters long, but actually a varchar string could be much longer. However, once I select varchar, I should specify a maximum length for it, and I will specify 191. For the length of the varchar, this is something that I've been doing historically, but because we will store names here, 191 should be more than enough. You can change this value if you want, but I think you can go with 191 without a problem. I want to have a column called sold items. And actually I think we can go with integer here. But I also want to have a column for the sales region. This column will show us in which sales region the salesperson made a sale or sold the items. I can make this a varchar column, and I can specify a length of 191 for it. And we're pretty much finished. We don't have to deal with the other options here. But before I click on save, I will actually click on preview SQL. Here we can preview the SQL code that will be executed. So this is SQL for creating the sales data table inside the sales database. We will not start analyzing this SQL, of course, but now I just wanted to show this preview SQL functionality to you. I will click on close, and actually I will click on save, so my sales data table will be created. And actually the table has been created successfully. You see that we have the sales database here and we have the sales data under it. If I click on it, I see the columns, so ID, name, sold items, and sales region. But of course this table is empty at this point. We could click on this new button to add a new table to the sales database, but of course we don't want to do that now. At this point, we would like to add some data to our sales data table so that we will be able to retrieve it later using SQL in our VBA project. Select the sales data table and click on Insert. We will add some rows to our sales data table. We don't have to add an ID because we've specified the ID column as an auto-increment column, so an ID will be assigned automatically to the row. As for the name of the salesperson, I will put John Edwards, for example. With a capital J, of course. And let's say that John sold 600 items, and he sold it in the EMEA region. EMEA stands for Europe, Middle East and Africa. I can simply click on Go here, and now I see the message one row was inserted, and it received the ID 1. And actually we could see the SQL that was executed to insert a row into the table. But now let's insert another row to the table. Let's have an Emily Smith. She sold 1,200 items in the APAC region. APAC stands for Asia Pacific. I will click on Go. And now I have two rows in my table. Actually, if I click on the sales data table, now you see that we have two rows. So we have the row with the ID of 1 and 2. We have John Edwards and Emily Smith, and we see their sold items and the sales regions where they completed the sale. I will insert a few more rows into the table. I will have a Jane Freeman. She sold 2,500 items in the NORAM region. NORAM stands for North America. I will insert another salesperson called Philip Gates. He sold 630 items in the APAC region. I will click on Go. I will insert a Blake Johnson, who sold 1,000 items in the APAC region, let's say. I will click on OK. And I will insert a Paul Waters, who sold 800 items in the EMEA region. I will click on my sales data table. So now I have a few rows in my table. It's not much data, but we can start working with it. Select your sales data table and click on SQL. We can write SQL code in this query box. We can run it and then we can see what our query returns. This query box is pre-populated, but let's delete the where one from the end. And let's also delete these backtick characters. We can enclose table names with backtick characters in MariaDB, but we don't have to use them. Actually, now we have a completely valid SQL query. In SQL, we use statements or keywords to let SQL know what we want to do. I actually prefer to use the term keyword, so I will say that we start our query with the select keyword. And as its name suggests, we use the select keyword when we want to retrieve data from a table. Then we have this asterisk or star character, but we could also translate it as all. So we could say select star or select all. If we use the asterisk, it means that we want to select all the data from the sales data table. So we want to retrieve all the rows and all the columns. After select star, we use the from keyword, and after the from keyword, we specify that we want to return all the rows and columns from the sales data table. Of course, with the from keyword, we specify from which table we want the data to be returned. We have actually selected the sales data table, which is inside the sales database. So now we don't have to specify from which database we want the data to be returned. So we can understand the SQL query as select all the data from the sales data table, or retrieve all the data from the sales data table. Let's click on Go, and here we see that 6 rows in total were returned, and the query took very little time. And we see all the rows that have been returned. So of course, because we selected everything, so we used the star here, all the rows of the table and all the columns of the table have been returned. Let's click on Show Query Box, and let's add a semicolon to the end of this query, and let's click on Go. The result is actually the same, so the semicolon didn't really change anything. But when writing SQL code, you will see that many people add a semicolon after each command or statement. The semicolon separates SQL statements. We only have one statement here, so we want to do only one thing now, retrieving all the data from the sales data table. So actually we don't have to use the semicolon, but actually I prefer to use it. The point is that the semicolon separates SQL statements, so separates SQL commands or valid pieces of SQL code. Regarding the terminology, I would like to mention that in SQL we can refer to rows as records, and we can refer to columns as fields. If you use the term row and column, of course people will understand you, but it's more usual to use the terms record and field. Now we have written and successfully executed our first line of SQL code. But we have done it in PHP admin only, and of course our main goal is to use SQL in our VBA code. So let's set up VBA for SQL. If we want to access MariaDB from our VBA code, then we will need a so-called ODBC driver. An ODBC driver allows applications to access database management systems, and basically what we want to do is to access the MariaDB relational database management system through an Excel application. In Google, search for MySQL ODBC 5.3 Unicode driver, and you can click on the first result from dev.mysql.com. Of course, I will provide this link to you, but in case it changes, you can just simply search for the driver in Google and click on the first result from dev.mysql.com. My operation system is Windows 10, so I will not change this option, but I will change this option to 64-bit. And I will download the MSI installer. You can just click on this link below. No thanks, just start my download. Once the download is finished, click on it. Once you're in the setup wizard, click on Next. Accept the terms in the license agreement, click on Next. A typical setup type is good for us. And now we can click on Install. And it has been very quick, fortunately, so let's click on Finish. Once you've finished downloading, search for Administrative Tools. So click on Windows Administrative Tools. I'm using a 64-bit operating system, and I'm also using a 64-bit Office. So I will click on the ODBC Data Sources 64-bit. If you're using a 32-bit operating system, or if you're using a 64-bit operating system but a 32-bit Office, then you should click on the ODBC Data Sources 32-bit option. But I will go with the 64-bit option, so double click on it. Go to the System DSN tab, click on Add, and select the option MySQL ODBC 5.3 Unicode driver and then click on Finish. Now we have to configure our data source. It doesn't matter what our data source name is, but I will add the name phpMyAdmin. We don't need a description for it. In this field, so the TCP/IP server field, you should put localhost. So it means that we want to connect to our local MariaDB. Add the username root to the user field and add the password to the password field. My password is 12341234. In case you have chosen a different password, then of course add that password here. Now if you click on this arrow, you should be able to see the available databases. Select the sales database and click on Test. If you see this message box that the connection is successful, then you're OK. Delete the sales from the database field and click on OK. If your driver has been added to the system data sources, then you're OK, so you can click on OK. Now that we have successfully installed the ODBC driver, we will be finally able to use SQL in our VBA code. I have opened the Setting Up VBA for SQL.xlsm workbook. Let's go to the Visual Basic editor. I have 3 modules in this VBA project: the Helpers module. I also have a Delete Records module. But now we will talk about the SQL Helpers module. I have a subroutine here called Manager Sub. I have declared 2 string variables here, the connection string and the SQL query string. The connection string will hold the string that we will need to connect to our database. So actually it will hold the necessary information for connecting to our database. And the SQL query variable, of course, will hold the actual SQL query that we will want to run against the database. You might have heard the expressions running a query against the database or executing a query against the database. It just basically means to do something with a database through SQL code. The connection string is quite a long string, and it has to be in the format that you see here. It has to start with driver equals, and then inside curly braces you have to specify your driver, your ODBC driver that you are using for accessing the MariaDB database. If you've installed the driver with me, you don't have to change anything here. But if you are working with a different driver, then do not forget to change the driver info here. Our string continues with server equals, and I've mentioned earlier that 127.0.0.1 is just another way of referring to localhost. So here we specify that we want to connect to our local database. On the next line we specify that we want to connect to the sales database that we created. On the next line we specify with which user we want to connect to the database. And on the last line we provide the password for that user. The bad and weak password that I'm using is 12341234. On the next line of code we are actually writing our valid SQL query, but we will store this SQL query in a string variable, the SQL query variable, so make sure that you wrap your SQL statement inside double quotes. On the last line of code here we are calling the getDataFromDB subroutine, and we pass the connection string and the SQL query variables as arguments to it. This subroutine is here. I will make the immediate window a bit smaller. But basically this is the subroutine that will get the data from the database. So this subroutine will run our SQL query, and it will also populate our Excel worksheet with the data that was retrieved from the database. For now, let's just check if everything is working. Our SQL query will be select all from sales data, so we want these 6 rows to be returned. Let's go to our worksheet. I added the Manager Sub macro to the Quick Access toolbar, so simply click on it. And it seems that everything is working correctly. I will zoom in a bit. So indeed, we have 6 rows and 4 columns. So we have the ID column, the name, the sold items, and the sales region column. And it seems that all the data is correct. So what we've done now is huge. We have taken data directly from a database using VBA, and we populated our Excel worksheet with that data. I have also added the Delete All Records subroutine to the Quick Access toolbar. If you click on it, then all the data from this worksheet will be deleted. So it will be quite convenient to run the manager sub multiple times if you want to. So I can run it again actually, and I can confirm that everything is working still, and then I can delete all the records. And if I wanted, I could go and change the SQL query here, and then run the manager sub again. And of course I could delete all the records and change the query again and again and again. You get my point, I hope. So now we have a simple and convenient way of getting data from our database and populating our worksheet with that data. But we don't really know what the get data from DB subroutine does. I forgot to mention that if you want to connect to a database and run SQL code from VBA, you have to add a reference in your VBA project to an object library. Go to Tools, References, and if you are not using My Files, then you should make sure that the Microsoft ActiveX Data Objects library is referenced in your project. Otherwise, you will not be able to connect to your local database and run SQL queries. You might not find version 6.1 in the list, but it is not a problem. Just reference the version that is available to you in this list of available references. The get data from DB subroutine takes two arguments. The first argument is the connection string. This is the string with the necessary information to connect to our database. Previously, we have seen how we concatenate this string and what data we include in this string. The second argument is the SQL query argument, which is the actual SQL query that we will run against the database. On the first line, we declare a connection object variable, and we immediately instantiate a new ADODB.connection object. This object is part of the Microsoft ActiveX Data Objects library, which we are referencing in our project. On the second line of code, we have a record set object variable, and we are immediately instantiating an ADODB.recordset object. This object is of course also part of the Microsoft ActiveX Data Objects library. The remaining variables are not that interesting. We have a variant variable, which as its name suggests will be an array, and then we have a bunch of lon variables declared. On the next line of code, we call the open method of the connection object, and the connection string is passed as an argument to the open method. On this line of code, we are establishing a connection to our database. On the next line of code, we call the open method of the record set object. The first argument is the SQL query, and the second argument is the connection object. We call fields and then count on the record set object, and what this returns is the number of columns or fields that were returned, and we save this number into the field count variable. In this for loop, we are adding the header to our worksheet. In other words, we are adding the field names to the first row in our worksheet. Let me go to the worksheet and run the manager sub. So basically in our for loop, we are adding these 4 fields to our worksheet. Then we are calling the getRows method of the record set object, and what is returned here is a 2-dimensional array that we save into the record array variable. We save the upper bound of the second dimension of this record array into the record count variable. In the second dimension of this array, we will have the rows. The indexes in the first dimension of the record array are for the columns, and the indexes in the second dimension are for the rows. Actually, I think I shouldn't have added +1 here, because in the loop below, actually I'm subtracting 1 from the record count. So I think that these arithmetic operations are unnecessary actually. But it is now too late to change that, and the code works fine. Here we are having a nested loop. In the outer loop, we are looping column by column, and in the inner loop, we are looping row by row. In this for loop basically check-in, if we find a piece of data that is in the date format, or if we find a piece of data that is in an array format. So basically we are checking if the column or field has a date type, or if the column or field has an array type. If the column has a date type, then we are calling the format VBA function to format the piece of data correctly as a date, so that when we are writing back the data into Excel, it will be in the correct date format. So we will be able to work with the dates from SQL as proper dates in Excel. Array fields are kind of special, and we cannot really transfer them into Excel. So if in the worksheet you see the string array field, then it means that the data contained in that cell is in an array format, and that we cannot process properly in Excel. Next, we are getting the upper bound of the first dimension of the array, which stands for the columns, and then we get the upper bound for the second dimension of the array, which stands for the rows or row indexes. We have again a nested loop. In the outer loop, we are looping over the column indexes, and in the inner loop, we are looping over the row indexes. And this is actually the line of code where we populate our Excel sheet with the data from the record array. And don't forget that the record array contains the actual data that was returned from our database. The array is indexed from 0, but in Excel column indexes start from 1, so we have to adjust the column index here when we are assigning a value to a cell. And we also have to adjust the row index of the cell, of course, because in the array the row indexes start with 0, and of course in Excel row indexes start with 1. But we have to adjust this index a bit further, so we have to add +1 again, because we already have our header in the worksheet. So in our loop, when the iRow variable is 0, then actually we want to put data into the second row. So we don't want to overwrite our header. Before the subroutine ends, the columns are auto-fitted, so the data looks better. So this is the subroutine that actually connects to our database and runs the SQL query, and it also writes into Excel what has been returned by the query. Actually, a lot of things are happening in this subroutine, and I think it would be better if we could separate some of the logic into other subroutines. But now we are learning about SQL and databases, and probably it is less confusing that we have one big subroutine where we have all the logic than having many subroutines that contain only part of the logic. So now we know what VBA is doing to get the data, and we also know how the data is written to Excel. So now it's time to focus more on SQL.